Hello there. My name is Marco Lisenek, and I will be giving you guys an introductory lecture on what a smart contract is, but mainly I will be showing you how to write a simple one. This lecture is for those of you who already have an understanding to what Ether and cryptocurrency is, and hopefully have some background experience with coding in JavaScript. If you don't worry, I will give a brief overview of what everything is and how it works before we start the live coding demo. In this lecture, I will briefly go over what the Ethereum blockchain is and what smart contracts are and why they are useful. I will also go over what tools you will need to interact with smart contracts and what tools you will need to write a simple smart contract. After that, I will show you in a live coding demo how to write one. Fun, right? Alright, let's get started. As a basic overview, the Ethereum network is essentially a network of computers that are hosting smart contracts on the Ethereum blockchain. These smart contracts are used to transfer money in the format of Ether. You can think of the blockchain as a database that stores a record of every transaction ever made. I will go over what smart contracts are in a few seconds, but essentially, people write them with code and then they deploy them onto the blockchain. These smart contracts contain functions which are then callable once they are actually deployed onto the blockchain. MetaMask. What is MetaMask? MetaMask is a Chrome extension that literally anybody can download, and it is used so people like you and I can interact with the Ethereum network. It allows you to create an Ethereum account, which can be thought of as an email address. The account is a long string of letters and numbers which is used for sending and receiving money. If you know someone's account, you can send them Ether. It also allows you to deploy smart contracts onto the blockchain. So enough about smart contracts. I've been talking about them for so long and we still don't know what they are. A smart contract is essentially an Ethereum account controlled by code. The code of the contract defines how the contract will handle transactions with people's Ether. Using your own account, you deploy the contract to the blockchain, and after that happens, people can access it and interact with it in many different ways. Alright, so there's my brief overview, so let's get right to coding. How to write a simple smart contract. First things first, open up your internet browser and visit this website, remix.ethereum.org. Remix is essentially a testing platform for contracts you write. You have an interface to write code on, so let's just focus on this part of the screen for now. You can write whatever you want here. So, how do we write a smart contract? Do we use JavaScript, or Ruby, or C++, or Japanese? No, we use a language called Solidity. To first start out writing our smart contract, we first have to tell the program what version of Solidity we'll be using. Now, the newer versions of Solidity may be buggy depending on how you write your smart contract, so I recommend using 0.4.18. So in order to define what version you use, you simply write at the top of the page, pragma, solidity, upcaret, 0.4.18, semicolon. So I cannot stress this enough. If you're familiar with JavaScript, semicolons can be either here or there. You don't need them, you kind of need them, but you don't really. In Solidity, they are a necessity. You need semicolons at the end of every statement you make, or else your code will not compile and everything will break. So just please remember to put in semicolons. Alright, so now that we defined what version of Solidity we'll be using, let's write a simple smart contract. And I propose to write one for the popular website that will essentially do the same thing as the popular website GoFundMe. If you're not familiar with GoFundMe, it's essentially a platform for you to ask people for their money so you can help someone in need or go on a trip or pay for school or pretty much do whatever you want with it. So, next we define the contract. We define the contract by writing the keyword contract and giving it a title. So I'll call it Go Fund Me, and then I'll open up some brackets. Inside this contract right here, this is where the majority of this is where the entire function, is going to be. So now that we have defined what our contract is going to be called, we next have to set up a function that will deploy it onto the blockchain. And we do this by writing a constructor function. The functionality is a little similar to, if you're familiar with JavaScript constructor functions with objects, but the syntax is a little different. So bear with me here. First, we start off by saying function go fund me invoked public bracket. And inside this bracket, I'm going to write manager equals message dot sender semicolon. Whoa, I just did so much stuff, and you're probably saying like, hey, what's going on, Marco? You didn't tell me about any of this stuff. What is public? What is message dot sender? Where the heck is manager coming from? So I did get ahead of myself, and I did do something I shouldn't have done. I forgot to define what manager is, because a manager is essentially, oh, whoops, I spelled it wrong. Manager is essentially a variable that we're going to define, and you define variables in Solidity like this: address, public, manager. So you define what type of variable it's going to be. You then use this public keyword, which I will get into, and then you say what your variable is going to be called after. And then, of course, don't forget your semicolon. So now, public. What is public? Public is a keyword that goes after any definition and of either a variable, a function, anything like that. So public basically means that anybody that is accessing our contract can call these functions. The other word you can use instead of public is private. Private essentially means that another person cannot call this function, but the only things that are allowed to call this function are other functions inside of the contract. So this doesn't really make sense to make this function private, so I will leave it as public. And here we are setting manager to equal message.sender. Message.sender is essentially an alias for the person's MetaMask account, their account number. So the person that is invoking this function is launching an instance of this function onto the blockchain of Ethereum, into the Ethereum network, and the manager of this contract, the person who's making their GoFundMe, is the person who's calling it. Now there's another aspect of this contract that we've written so far that you're probably a little confused of, and that's probably this word address. Address is a data type in Solidity. Address, you give a variable the word address if it's going to be a person's like a MetaMask account number or anything like that. Other than that, there's also uints, there's strings, there are structs, and also mappings. I won't get into these too much except for this address, but just know that they're there and do some research on your own if you want to know more about them. Okay, so now that we have a way to make an instance of this contract and deploy it onto the blockchain, what's the next thing we need to make a successful GoFundMe account? We need a way for somebody to go onto my contract and call a function that allows me to donate to their cause, right? So I will write another function, I'll call it donate. I'll invoke it. I will add the public keyword. I will also add this other keyword called payable, which I will get into in a minute. And inside here, I will leave it blank for now. So let's talk about what's going on over here. Oh, I'm so sorry for all my spelling errors. But anyways, I defined a new function, and I gave it the name donate. It is public, so anybody is allowed to donate to my campaign, my GoFundMe contract. This keyword payable, this is the thing that makes this function take in another person's money. This makes it take in someone's ether. So when a function is payable, a person sends in a value of ether, and that ether is stored onto the contract instance. So you can think of the contract instance as kind of a bank. So to spice things up a little bit, I'm going to write this statement here inside of this donate function. It's going to be a require statement. So we will require message.value to be greater than 1 ether. So you must be saying, "Whoa, what's you're going crazy again, Marco. I don't know what's going on." So let me tell you exactly what's going on right here. So a require statement is essentially like an if statement. So this function requires whatever is inside of its parentheses to be true, or else the function does not run. Now, here, message.value, if you can use context clues, it is very much like message.sender, but it is a reference to the person's amount of ether that they will be sending into the contract to donate. So I'm saying that this is required, the message.value, to be greater than 1 ether. If not, then this function does not run. So now I need a way for if I'm starting this GoFundMe campaign, I need a way to get the money that is stored onto the smart contract, right? Like let's say I'm going to college, I set up this GoFundMe and I set up this donate function, and I set this required because I don't want like people to donate like $2. What's $2 going to do for getting to college, for getting like paying for college in this day and age? Why I need 1 ether. I need at least 1 ether. So now I need a way to get all the money so I can actually go. So I'll write function withdraw. I'll call it withdraw since I'm withdrawing from the contract. So I'll invoke it. I'll say public. Oh, whoops! Not inside the parentheses. Nope, we're not doing anything inside there. Public. Open bracket, and I will do message.sender.transfer this.balance. Semicolon. Please do not forget these semicolons. They're very important. So, as you may have guessed, the message.sender, the person calling this function, will, when you .transfer off of it, you are saying that whatever goes inside these parentheses that is being invoked with .transfer, that number will be sent to that person's account, which is the message.sender. And in this case, that value is this.balance, which is essentially an alias for all of the money that is on the smart contract. Alright, so we have a pretty good-looking functional smart contract right here. So now, if you've been paying attention to me, however, you might notice a very glaring problem. So let's say that I launch this GoFundMe campaign, a bunch of people donate a bunch of ether to me, and some guy comes along and he's like, wow, that's a pretty good GoFundMe campaign. I want to take all the money they're collected and spend it on something else, because I'm a jerk. Right now, that is completely doable. All they have to do is call this function because it was made public. If this function was made public, that means anybody can call it. So, what is a way around this? I could just write another require statement, but I want to offer you exposure to another fun thing about Solidity, which will be useful when you write more in-depth contracts, and that is a modifier. So let me first write out what this modifier will look like, and then you'll probably be able to guess what its functionality is. So I will write modifier. I'll define that it's going to be a modifier. I will give it a name. So I'll call it, I don't know, I'll call it restricted. I will invoke it. I will open up my brackets. And now I will place my require. So my require will be message.sender will be equal, double equal, not triple equal. Solidity does not understand what triple equal is, so always double equal. Equal manager. Whoops. Manager. Semicolon. And then on the next line, underscore, semicolon. Okay, so what is going on in this line of code? You define that this is going to be a modifier and you give it a name. In this name, in this modifier, you basically define a require statement. So you're requiring that the message.sender has to be the manager, has to be the person that deployed the instance of this contract, the person who is starting this GoFundMe. This underscore and semicolon is required for every modifier you make to be on the final line of this function. So now, how do you write this how do you incorporate this modifier into this withdraw function? It's very simple. All you do is write restricted here. And now, whoever wants to withdraw all the money in their balance needs to be the manager of the contract. Alright, so everything looks pretty good. So I will now show you how to use Remix to test this function to make sure it's all good. So, just in case you think I've been lying to you this entire time. So you go over here on the right hand side and you press this run button. Now make sure your environment here is selected to JavaScript VM. Selecting JavaScript VM essentially means that under this account dropdown, it gives you 5 completely random accounts with fake ether in it, so you can send it and play around with it, do whatever the heck you want with it. Gas limit, I'm not going to get into in this lecture, but I will. Okay, I'll glance over it briefly. Essentially, gas. At any time you deploy an instance to a contract onto the blockchain, you access that instance, you change any data on the blockchain, anything like that, that costs gas, and gas is real money. Anytime you alter anything on the blockchain, think of it as a tax. It costs a little bit more extra money. Then this value is essentially if we will be paying, when we call this donate function, we will send in how much ether we want to here. And you could change this to Finny or GWay or WAY, but we'll be using ether because that's the easiest to understand. Alright, so I will select this account and I'll say, hey, I want to go to college, I want to start a GoFundMe, please help me get into college, so I will create this instance of this contract. You could see all the status of the interactions and transactions happening on the gray terminal down here at the bottom of the screen. So now over here you may notice that an instance of your contract has popped up. And you have a manager button, a donate button, and a withdraw button. If you could click the manager button, and it will basically log out the address of the manager of the contract. So CA35 right here. It's the same thing. So now I'll switch to this account. And you may have noticed that I no longer have 100 ether. I now have 99.999999792.172 ether. That's because deploying anything onto the blockchain costs gas. So now I'll switch to this account, have 100 ether. I say, hey, that guy, he looks pretty swell. I'm going to give him 50 ether. That's a lot of money, but whatever. I'll just give it to him. I hope he goes to college. So I'll press the donate button, which will invoke the donate function. Once I do that, you could see that it's pending, and then you could see it's received. And you see it's worked because the person has, this account number now has 49.99999 ether. So that ether, you can't see it right now, but it's essentially been stored onto this GoFundMe contract instance. So then this guy comes along and he's like, hey, I also want to give, I don't have that kind of money, but I do have a little bit, so I'll give him 10 ether. So, actually, I'll just make it simple. I'll just make it 50, increments of 50. I'm rich too. I'll give him 50 Ether. So now I'll donate. Once again, my Ether goes down to 49. You see the transaction pending and you see it accepted. So now, essentially, there's 100 Ether stored in this contract. So now I have to switch back to the first account because remember this restricted modifier over here. I cannot withdraw from this smart contract if I am not the person who deployed it. If this is not my GoFundMe, I cannot access it. So I will then go down to the screen over here in the bottom right and click the withdraw button. If everything goes well, I will have 199 Ether. And it's really that simple. It's that simple to write smart contracts. Of course, when you try writing your own, things will get a little more messy. You'll make it more like this is extremely simple. This is probably the simplest smart contract you could ever write. But you know, it gets messy quickly, but it's really not that hard. All right, so that's all I got for you, honestly. I hope you took something away from my little tech talk. But, you know, if you have more questions on Solidity in general, I recommend you visit this site right here. Oh, God, if it loads. My computer's being awfully slow right now. But if you go to cryptozombies.io, it's a very fun interactive course. Oh, here it is. It's a very fun interactive course that gives you lessons, and it really helps you understand the syntax and the syntax of Solidity and how smart contracts actually work. Also, I recommend checking out Stephen Grider's Udemy course. It's called Ethereum and Solidity, the Complete Developer's Guide. Stephen goes through one of the greatest courses I've ever watched, and he explicitly gives you great advice and great history lessons and details on everything like that, on how to write JavaScript applications that interact with the Ethereum network. Both are very intuitive and both are extremely helpful, so I do recommend them. Okay, well, I hope you enjoyed listening to me, so if you have any more questions, obviously, check out these two sites, or feel free to just watch this video again. Alright?